Did this turn off? It must have. I think so. I think so. Okay. Right. 1E. Let's see, you've got F, and then you've got G. So what happens when we add these together? Yeah, how do we draw that? No straight line? Dot? Dot? Yeah, well these add together. If you put, for example, this tail onto this head here, and then it goes back to the start. Or as a lot of people notice, they cancel. So, the dot is the answer. This is called the zero or null vector. That's okay? Yeah? Okay. I can scroll down? Yeah. Right. D, E, and then F. And I ask you to add D, E, and F. And as I was saying to Yusra or Lena, do you think here the order is important, which way you add them together? So you could do it this way, D and E first, or E and F first, and then D later. Do you think the order matters here for the answer? No, it doesn't actually. You get the same answer. So what we'll do is we'll add D and E first, and then add the answer to F. So here is me adding, let me make some more space. Here's me adding D and E together. So here's D plus E. That's D plus E. Then I add D plus E with F. And here is D plus E plus F. So you have to do it in steps. First add two together, and then add that resultant with the last one. Okay, so if we write this one down, now we'll go on the tree here. Well, E and F are kind of the same. Okay, so I'll do -1 and then a remark. Okay. Can I go down? Yeah. So suppose I have here X and Y, and I ask you to do X minus Y. And you might think, well, you only showed us how to add, not how to subtract. But this is the same as adding, because this is the same as x plus minus y. So first we have to get minus y. Here it is here. Then we have to get x. Here it is here. And we add them together. And here you go. Here's x plus minus y. X minus y. So if we can write this example down. You drew that? Yeah. Okay, and the last thing to say about this lesson is that we can use our algebra rules on vectors as well. Not all of them, but some of them. For example, if you have A of vector x and you want to add it to B of vector x, then that's the same as A plus B of x. So for example, if I have vector 2x and I want to add it to vector 3x, that is the same as 5x. So for example, here is 2x and then here is 3x, and yes, if I add them together, of course I get 5x's. 5x. So you can use the algebra rules to simplify a little bit here. Other algebra rules which are true: x plus y is the same as y plus x. That's another one that's true. Okay, you got that? Yeah? Okay, so we'll have a look at the next lesson then. Yes? F? Oh, F is easy peasy. Here. 2a minus 2b minus 2a minus 2b. That is minus 4b. And if I look at the picture, b is going like this in the picture. So minus 4b will be this vector. That's the answer then. Unhappy? Very unhappy? If this is b, then this one here is minus 4b. So Yusra, what I was saying with this one is we can cancel the 2a and the minus 2a like algebra, and then minus 2b and minus 2b is minus 4b. Yep. For the first lesson, we're drawing arrows. Okay. So it's not always convenient to draw arrows all the time. So we're going to look at another way to be thinking about vectors. So they're still vectors, but we call them Euclidean vectors. Does anybody know this guy's name? Euclid? No? Yeah. Firstly, male, yes. Euclid? No? Nobody's heard of this guy? No. He was with, think back to Pythagoras and his friends. Okay, so the only reason I'm telling you about him is he's very important in maths because he had like the first maths book, and I thought somebody might have heard of him. The name of his maths book is Elements. No? Anyway, it's important because there was a maths book used in school for about 2,000 years. So his was the school maths book for 2,000 years. All the way up to Newton. So successful maths book. It was the standard maths book for 2,000 years. And you never heard of him? No. It changed around about the time of Newton when, Newton invented new maths. What maths did Newton invent? No? Calculus. Anyways, Euclidean vector is a more precise way of drawing our vectors, and it's by using shapes. So for example, if I have a square and I call this side here A, B, C and D, when I write this AB with an arrow above it, what vector do you think that represents? What do you think that I might mean by this?
A to B.
Yeah, that means this vector, A to B. Now in this example, it's interesting because it means that's the same as some other vector. There's another vector here which is exactly the same as AB. DC, yeah. These are the same vector. So no surprise here, we can say AD is the same as BC. Now, I want you to give me something which is the same as AC. Oh, definitely not.
D.
Say that again? No, you were close.
Square root.
No, not
D
no.
plus B. D plus square.
No. So look. Listen, Ty. Think about it. AC is the same as AB plus BC. Huh? Why would it be square? Why would it be square rooted? But did I use Pythagoras in the last lesson? One example. But do I need to use Pythagoras to add vectors together? No. This is the problem with the chapter on vectors. The further you go into the chapter, the more difficult it gets. And the difficulty is with the ideas, not with the maths. So here I'm saying AC is the same as AB plus BC. Why did I say AC is definitely not the same as BD?
Because
Different direction, yeah. AB is pointing which way?
Northeast.
Northeast. And BD? Northwest. Yeah? Okay. Right. So let's have a look at something a little bit, a more complicated picture here. Can I scroll down? So what I'm going to do is I'm going to draw a rectangle. A, B, C, and D. And I'm going to tell you that the sides are in a proportion of 2 units on the horizontal and then 1 unit on the vertical. So they're a 2 to 1. It's a 2 to 1 rectangle. Do you understand what I mean by that? That this side is twice this side. Yeah. Okay. So what I want you to do for me is to write let's see. Yeah, we'll do an easy one first. Write AC. No. Oh, okay, an easy one. Write AC in terms of AB and AD. In fact, for all of these questions, I want you to write them in terms of AB and AD. So I'll just give you a minute to try that. Should only take a minute. I want you to write AC using AB and AD and no other vectors. I'll make some space. AC. Now if you look at this, you could say AC is the same as, look closely, AB plus BC. But BC is the same as what vector? AD. So you could say this is AB plus AD. So that's the answer for that one. Now let me give you another one. We'll make them a little bit more difficult. So what I'm doing is I'm putting a point here right in the middle of DC. So now I want you to give me AM in terms of AB and AD as well. Okay, yeah?
Can I say AM is equal to AC, which is equal to AD plus?
AM equal to AC? Oh, they're definitely different. Absolutely. They point in different directions. Not the same, exactly the same. AM is steeper than AC. Do we have something for AM?
AD minus AD.
Yeah. AM is equal to AD plus DM, firstly. Can you see that? AD plus DM. But DM is actually a half. A half of what? AB. Or if I'm just adding in more steps, it's a half of DC. But what's DC? It's, yeah, very good, it's AB. So this is the answer, AD plus a half AB. Okay, I'll give you another one here. So here is N. So now I want AN.
What is it?
That is?
BC.
You have AN? Yeah? So let's have a look. AN is AB plus BN. AB is AB, but BN is a half of BC. And what's BC? AD, isn't it? Okay, one more for this rectangle now. MN. And I'll give you a little hint actually to help you. If you have the vector AB, here it is here, it might help you to know that this is the same as minus BA. So if you look here, there's AB, there's BA, and then here is minus BA. It's the same as AB. This might be useful. AB is equal to minus BA. You might find that helpful. Got it? So what's MN?
Half AB plus half AB.
Half and
No.
minus MC plus C.
Final answer. Yeah?
half AB plus half D.
Possibly. I think so, yeah. You said a half AB...
Plus half D.
Almost minus a half AD. Yeah, we need to swap it at the end. Let's have a look here at MN. Now, there's a couple of ways of doing it. So the first way to do it is you look at the diagram. This is MC plus CN. What's MC? A half AB, yeah. And what's CN? As you said, Ibrahim, a half DA. When you CN is a half DA. But we just need to fix it so that's AD. So this is a half AB minus a half AD. Now I said that's just one way to do it, so I need to remove this and show you the other way to think about it. So first write this answer down. Yeah? You got this? Yes? I'm going to remove it. Okay, that's one way. Now the other way to think about it is like this. You can use the answers you got previously. So you could say MN is the same as MA plus AN. It's the same as M to A and then A to N, which is the same as AN minus AM. I just swapped the M and the A, made it minus AM. And the reason for doing the swap is if you look carefully, you can see that this here is my answer to part 3, and this here is my answer to part 2. So I could say my answer from part 3, which is AB plus a half AD, minus my answer from part 2, AD plus a half AB. So AB minus a half AB, how much is that? AB minus a half AB. Try again. Half AB. And then a half AD minus AD. Minus a half AD. What answer did I get when I did it the other way? The same. Now that's actually important because sometimes in the exam and sometimes in the workbook they give you multiple parts to a question, and then it's much easier to do the last part of the question if you combine your answers from the earlier parts. So if the question has 3 parts to it, often part 1 or part 2 or both can help you with part 3. Now in this example here, the last part was not too difficult. I didn't need to use my answers from part 2 or part 3. But I'm telling you now that for some of these questions, it's much easier to do it if you can use your earlier answers. Okay, let me just have a look at some of these pictures. Now, I think, let me just check the questions here. I might have made some changes to some of the pictures. Let me just check. What's wrong? You can ask me questions, don't be shy. Science and engineering, vectors, Euclid. How many questions do you have there? 4, is it? Okay, I just want to make sure, because I think there were some problems with the questions or the answers. So in the first one, is it CD? If you just check, CD, yeah, look at your book, I'll read them out. CD, DB, AC, AM, CM. Yeah? And then in the second one, BC, CX, XD, AD, BE. Yeah? And then in 3, AX, BX, AD, BC, AB. Yeah, and I ask for in terms of AD or BC.
Or AX or BX.
Ah, okay, so this is where the mistake was. So can you just change in your book this one here?
You change the AX and BX?
It should say, this is the correct one, it should read like this. Oh, it is the same? Hey, and these are the same then, yeah? Okay, and here it's AB and AF? Yeah, and then for the last one I think it's okay. BA and BC? Yeah, and then BH, HI, DE and BE? Yeah? Okay, so maybe there's a problem with the answers. So just have a look at the answers there. So do they look like they're matching up? Yes, 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 yes. Yeah. So, I either fixed the mistakes in your workbook or I forgot to fix the mistakes. Let's say I fixed the mistakes. Yeah, that's okay. So now we're starting to move into questions which are more like what you might get in an exam. Especially something like number 2. What's the name of that shape in number 2?
Hexagon.
Yeah, hexagon. Okay, okay. I'll let you try these for a few minutes. You should be able, you should be able to finish them before you go home, okay? Are you free after this class now? Yeah. So what room were you in for chemistry?
This room.
So you could even stay and finish them. Just an idea. Good idea if you ask me.